Hello students, welcome to DSR Maths. Today we are going to study number system, under which we are going to study rational number as recurring or terminating decimals. So before going to understand what is recurring or terminating decimals expansion, first we should know what is rational number. So first let us define rational number. So rational number is defined as any number which can be expressed in the form of P by Q or P upon Q. Now what is P and what is Q? So let me define it. So here P and Q are integers. What are they? They are integers, and you know what is integers. Suppose this is a number line where this is in center 0. Here 1, positive 1, positive 2, positive 3, and it goes on. Here negative 1, negative 2, negative 3, and it also goes on. So all these number which are represented on number line are called integers, right? So here in the rational form, P and Q are integers. One more essential condition is there, which is that the denominator Q should be not equals to 0. Why the Q should not be equals to 0? Suppose there is a rational number. Suppose it is 5 upon 0. So when 0 is in denominator, it actually becomes infinite. And infinite in itself is not defined, right? So we cannot say it is a rational number, right? So the essential condition is that the Q should never equals to 0. Now when we divide this P by Q, let's take any example. Suppose 7 upon 2, suppose, right? So when we divide this numerator by this denominator 2, let's look what happens. So 2 3s are 6 here, 1 is remaining, and point here 0, 2 5s are 10, which is 0 0. Now this 7 upon 2 is equivalent to 3.5, right? This is the decimal form of this rational number, right? Now this decimal form can be of recurring type, which is repeating, or can be of terminating type. Now what is the terminating and recurring type? Let's see one by one. Okay, so first let's see terminating decimals, right? So what is the terminating decimals? Terminating decimals is a decimal that ends after a finite number of digits. For example, as we have taken above, 7 upon 2 was equivalent to 3.5. Now this decimal expansion ended after this 5, right? There is no further expansion. Let's take another example, like 14 upon 2, right? So 14 upon 2 is, let's divide it. We know that it's no, it's not decimal expansion. Let's take 15 here, right? So 15. So 2 7s are 14. Here again this 1 is remaining. So point here 10, and it is also 2 5s are 10, which is 0 0. Now it can be written as 7.5. Now the decimal expansion is terminated after this digit 5. There can be more digits, right? So this is called terminating decimals. Now there is one essential condition for any decimals to be a terminating decimals. Now what is this condition? Let's look this condition. uh, condition for termination, right? So a rational number p by q will have a terminating decimal expansion if and only if the denominator which is q when expressed in simplest form when expressed in simplest form has only two